What if history isn't a straight road, but a coastline, drawn and redrawn by the tides? In the public imagination, the past feels settled. Museums give it clean labels. Textbooks assign it dates. Documentaries tie it up with a bow, a story with a beginning, middle, and end. Yet any working scientist or field archaeologist will tell you something quieter and more unsettling. The past is not a finished painting. It's a half-lit room. Every new lamp reveals what the shadows were hiding, and also what we mistakenly thought we saw. This story begins not with a grand discovery, but with a familiar human scene. A person kneeling in dust, brushing away a thin veil of earth, trying to understand the mark of something that lived, moved, and vanished. Sometimes that mark is a stone tool. Sometimes it's a line on sonar. Sometimes it's pollen trapped in ancient ice. And sometimes, if we're honest, it's a question that refuses to stay politely in its assigned era. Across the 20th century, there were expeditions whose findings did not fit neatly into the timelines people had learned to trust. A paleontologist peering at footprints where footprints shouldn't be. A marine geology team staring at geometric patterns on the seafloor that looked strangely planned. A drilling crew pulling up ice that held traces of warmth. Engineers tunneling under a modern city and meeting architecture that seemed older than the story that city told about itself. Now pause here, because the easiest version of this tale is the loud one. Heroes versus villains, truth versus cover-up, a hidden world held down by powerful hands. That narrative sells. It's also often too simple to be useful. The real tension is more human. Science isn't a single mind. It's a culture. Brilliant, cautious, competitive, collaborative, proud, self-correcting, and sometimes painfully slow to change. It runs on evidence, but also on incentives, funding cycles, reputations, peer review, the hard-to-measure cost of being wrong in public. When something new arrives that clashes with what is accepted, the first response is rarely celebration. More often, it's a long silence, a careful recheck, a request for stronger proof, a skeptical shrug. Not always out of malice, sometimes out of rigor, sometimes out of fear, sometimes out of habit. And yet the questions remain, because the ground keeps offering them. Picture a dry riverbed in Texas during a drought, bedrock exposed like bone. Locals point to impressions in stone and argue about what they see. A scientist arrives expecting misinterpretation, maybe even mischief. But the rock does not care what anyone expects. It holds its shapes with stubborn patience. Picture the Mediterranean at night, a research vessel moving across black water, instruments sending sound downward into a world no human eyes can reach. The readings return in clean lines and angles that feel oddly intentional. The team argues over what counts as natural. They know geology can mimic design. They also know design leaves fingerprints. Picture Antarctica, white, endless, silent, where drilling reaches into time itself. A core rises from below like a frozen diary. In its layers are clues: chemistry, dust, microscopic life. The difference between a stable climate and a shocked one can be the faintest signal, an impurity, a grain of pollen, a fragment of plant matter. In the polar cold, even a whisper can be preserved. This is the landscape of our series. 10 expeditions, 10 puzzles, and one overarching question. When evidence arrives that strains a timeline, what happens next? How do institutions respond? How do people respond? And how do we, as listeners, curious, skeptical, hopeful, hold two truths at once: that extraordinary claims require extraordinary care, and that human knowledge has always grown by stepping into the places where certainty ends? Because maybe the most important discovery isn't a footprint or a ruin. Maybe it's the moment we admit that history, like memory, is not a vault. It's a living conversation, and it is never finished. What if the ground could remember better than we do? In a dry season, when rivers shrink and the air tastes like sun-baked stone, the land sometimes reveals what it has been holding. Not because it wants to, because erosion is honest in a way humans rarely are. It strips away the soft cover and leaves behind the record, hard, indifferent, and strange. Along a limestone bed in Texas, the story begins with an argument you can almost hear before you arrive. A rancher points, a visitor squints. Someone insists the shapes are obvious. Someone else insists they're nonsense. And then a scientist arrives, carrying the quiet fatigue of having seen too many people mistake hope for proof. The first impression is always the same. The rock looks like rock, grey, pitted, ancient. It doesn't announce anything, but as you walk the exposed surface, you begin to notice depressions, oval impressions with a rhythm to them, as if something paced along the edge of a vanished stream. Some are shallow, softened by time. Others are sharper, like a sentence that has kept its punctuation. Footprints are a peculiar kind of evidence. They feel intimate. Bones are anonymous. A footprint is a gesture. It says, something walked here, with weight, with intent, in a moment of time. It's the closest geology gets to a moving picture. And that closeness is why footprints are dangerous. The human mind is built to see patterns. We find faces in clouds. We find meaning in noise. So the rules in the field are strict. Measure, photograph, cast, compare. Ask the rock to defend itself. The tension in this case is simple to describe and hard to live with. The impressions appear in layers associated with the age of dinosaurs. If they are what some people claim, human-like prints, then the timeline breaks. Not in a poetic way, in a practical way. It would mean either the prints are misread, misdated, or something about the accepted sequence is incomplete. Most investigators begin with the most ordinary explanation. Many of the human tracks, they argue, are eroded dinosaur prints. Three-toed tracks can soften, side toes can disappear. A long stride can seem like a heel-to-toe walk if the rock has been worn smooth. Water, wind, and time are skilled counterfeiters. So the expedition work becomes less about drama and more about patience. Teams map the trackways. They examine stride lengths and depths. They look for toe impressions, claw marks, pressure ridges. They study the sediment itself, how mud was laid down, how it hardened, how it cracked. They ask whether the tracks were made in wet silt or firmer ground. They compare the shapes to known dinosaur ichnology, because dinosaur feet, like any feet, have anatomical rules. But then there are the odd ones, the prints that refuse to behave like three-toed animals disguised by erosion. Prints with proportions that feel too symmetrical, too narrow at the front, too consistent across multiple steps. Or impressions that appear in sequence beside unmistakable dinosaur tracks, as if two different creatures shared the same shoreline within the same stretch of time. This is where the argument deepens. Not because anyone suddenly decides the extraordinary explanation must be true, but because the ordinary explanation stops feeling fully satisfying. In science, discomfort is a signal. It doesn't prove anything. It simply means the question is still alive. A careful team will do what careful teams always do: widen the lens. They'll check the stratigraphy. They'll confirm whether the layer belongs where people think it belongs. They'll look for redeposition, older rocks moved and relaid in younger contexts or younger sediments infiltrating older cracks. They'll consider contamination, misidentification, selective reporting. They'll ask whether the most dramatic prints are the best evidence or the most misleading. And the expedition ends, as many real investigations do, not with a verdict, but with a split screen. On one side, strong reasons to doubt human interpretation, and strong models for how nature can fake familiarity. On the other, a handful of stubborn details that don't neatly fold into the standard explanation. If you stand on that limestone bed long enough, you can feel the larger question rising like heat from the rock. Is history a clean ladder of progress, rung by rung? Or is it a tangled forest, paths crossing, tracks overlapping, evidence preserved in ways that challenge the stories we prefer? And if the ground can keep such strange records for millions of years, what else has it kept, waiting for the right drought, the right light, the right set of eyes to look again? What if the ocean floor held the outline of a city, drawn not in stone walls, but in shadows? At sea, truth arrives as a signal before it arrives as a sight. A ship moves across water that looks empty, and yet instruments below deck are busy translating the invisible. A pulse of sound drops into the deep and returns with a story. Slope, depth, texture, angles. The screen glows, lines form. A seabed becomes a map. Most of the time, the map is familiar. Ridges like wrinkles, canyons like scars, sediment fans spreading out like a slow-motion spill. Nature writes in curves and fractures, messy, complex, beautiful in its disorder. And then, sometimes, a shape appears that feels different. It's not proof of anything, but it triggers the oldest instinct in the human brain. This looks made. Off the coast of an island, where myths have always been part of the local weather, researchers charted stretches of sea floor that seem to arrange themselves into repeating geometry. Right angles, terraced steps, flat plains, edges so clean they looked cut. In the imagination, it's immediate. A sunken monument, a drowned platform, the skeleton of something built before the water rose. But imagination is not the ocean's only trick. Geology can create illusions with an artist's precision. Basalt can fracture into columns like a cathedral organ. Sandstone can break along bedding planes into slabs that mimic masonry. Underwater, currents can scour surfaces smooth and sharp. A cliff can look like a wall if you only see it from one angle. So the expedition is not a treasure hunt. It's a debate conducted with rope, sonar, and patience. Teams return with cameras mounted on submersibles. Divers descend where they can, entering a world of muffled sound and cold pressure, where distance is swallowed by darkness. They glide along edges that look like steps. They run gloved hands over surfaces that feel planar, almost architectural. They film corners that appear improbably straight. Back on deck, the footage plays again and again. The same images can tell different stories depending on what you already believe. Some see construction, others see jointed rock. Some point to what looks like a roadway. Others point to a fault line. Some see pillars. Others see natural columns. The scientists who are most careful do not fight with certainty. They fight with questions. What is the rock type? How does it fracture? Are there tool marks? Are there any artifacts, pottery, work stone, anything that carries unmistakable human intention? What is the age of the surface? Was the area ever above sea level when humans could have built there? How did sea levels change after the last ice age? And what shoreline would have existed when sea level rise is the unglamorous but powerful driver of these mysteries? At the peak of the last ice age, vast amounts of water were locked in ice. Coastlines sat farther out. Land bridges connected continents. Places that are seabed now were plains then, places where humans hunted, traveled, and lived. When the ice melted, oceans rose and those coastal worlds slipped underwater. If there were camps, villages, or ritual sites on those drowned shelves, the sea could have preserved fragments in a cold, dark archive. That possibility is not fantasy. It's a known mechanism. What's unknown is how much survives and how often nature's architecture will imitate ours. So the expedition's findings sit in a tension that feels almost philosophical. On one hand, the structures can be explained by geology, jointed bedrock, erosion, tectonic shaping. On the other hand, the geometry provokes a stubborn question. If early humans did build along ancient coasts, and we have good reason to believe they did, how would we recognize their work after millennia underwater? What would it look like when coral and algae have colonized it, when storms have broken its edges, when sediment has filled its gaps? The ocean is a master of both preservation and erasure. It can keep a shipwreck intact for centuries, and it can sand a coastline into anonymity within a generation. It doesn't care about our categories. It doesn't label what is natural or made. It simply acts. And that is the deeper lesson of this chapter. Sometimes the question isn't whether a site is definitively a monument or definitively a rock formation. Sometimes the question is about our own tools of recognition. How do we tell intention from pattern? How do we avoid the trap of seeing what we want to see, while still staying open to what we haven't imagined? The sonar keeps pinging. The images keep arriving. The seabed keeps its silence. And somewhere beneath the waves, whether it is art or accident, the geometry remains, asking us, in the calmest possible voice, are you sure you know the difference? What if the cold could keep secrets warmer than our stories allow? Antarctica looks like absence made visible. A continent erased into white, where horizon and sky blur into a single, pale decision. The wind doesn't just move, it sculpts. It writes over footprints within minutes, as if the place is practicing forgetting. And yet, beneath that surface, Antarctica is one of the best archives we have. Not an archive of human voices or ink, but of air itself, ancient atmosphere trapped in ice like breath held for thousands of years. To drill into the ice sheet is to travel downward through time. Each meter is another season. Each layer is a chapter. And if you listen carefully enough, the frozen layers speak in chemistry. Oxygen isotopes, dust content, trace gases, salt carried by storms long finished. The expedition begins with logistics that feel almost absurd. Planes and tractors crossing emptiness. Camps built like temporary punctuation marks on a blank page. Drilling rigs assembled in temperatures that punish bare skin in seconds. The work is slow, mechanical, precise. Nothing about it looks like revelation. Then the first core rises. It's a cylinder of ice, pale blue in places, milky in others, threaded with faint bands. Under the lights, it has a quiet beauty, like marble, but alive with trapped time. Scientists photograph it, log it, slice it into segments, seal it. They treat it like a fragile message. Because it is. What they want, at first, is straightforward: a clearer record of Earth's climate rhythm, how ice ages begin, how they end, how greenhouse gases rise and fall, how volcanic eruptions leave fingerprints, how dust storms mark drought. But as the cores deepen and the record stretches farther back, the simple story starts to fray. The accepted picture of the last several 100,000 years is one of cycles, cold periods, and warm interglacials, paced by subtle changes in Earth's orbit and amplified by feedbacks in ice, oceans, and atmosphere. It's an elegant framework. It explains a lot. It does not explain everything. In some cores, researchers find signals that suggest abrupt shifts, changes that happen faster than the slow, comforting pace we prefer to assign to geologic time. A spike in dust, a sudden jump in methane, a shift in isotopes that implies a rapid temperature change. Not the gradual turning of a dial, but the click of a switch. To the public, this can sound like the Earth behaving badly, like a system that isn't stable. To scientists, it sounds like a clue. The expedition teams compare cores from different sites, because one core can lie by accident. Local conditions matter. Wind patterns matter. Snow accumulation matters. A small distortion in one place can be mistaken for a global truth. So they cross-check: Antarctica against Greenland, deep interior against coastal margins, ice against marine sediments and cave deposits. They test, retest, argue, publish, argue again. And slowly, a more unsettling picture emerges. Climate is not always a slow pendulum. Sometimes it lurches. Sometimes it reorganizes quickly. Sometimes the boundary between before and after is thinner than we want it to be. This doesn't overturn history in the way a sensational headline would suggest. It reshapes it in a quieter way. It changes the emotional texture of the past. If climate can shift abruptly, then human history, migration, settlement, collapse, adaptation, may also have been shaped by sudden environmental turns. Coastlines could rise quickly enough to erase familiar routes. Rain belts could shift, turning grassland into desert within a few lifetimes. Cultures could be pressured not by slow decline, but by rapid change that feels like betrayal. The ice doesn't tell us about kings or wars. It tells us about conditions, what kind of world those people were trying to survive in. And it raises a delicate question about official timelines, not whether the past is fabricated, but whether it's simplified. We prefer stories with smooth arcs, but the planet's archives suggest something messier: thresholds, surprises, resilience tested without warning. Standing near the drill site, you can hear the rig's low groan and the wind's higher hiss. Two kinds of time moving together: human time, hungry for answers, and Earth time, indifferent but meticulously recorded. If the cold can preserve the air of a vanished world, what else might it preserve about the speed of change, the fragility of stability, and the thinness of the line between certainty and surprise? And if the past changed faster than we thought, what does that imply about the future we're building right now, in the warmth we've learned to take for granted? What if the oldest evidence isn't found in deserts or jungles, but beneath a city's morning traffic? There's a certain kind of irony in urban archaeology. People imagine the past as remote, far away, buried under dunes, hidden in mountain caves. But in some places, history is stacked like sediment. New buildings rise on old foundations. Roads flatten over forgotten streets. Generations live their entire lives above earlier generations, never hearing the quiet architecture beneath their feet. The expedition in this chapter doesn't begin with a ship or a caravan. It begins with a construction project. A new tunnel is planned. Subway, sewer, utility line, it almost doesn't matter. Engineers mark the route. Machines bite into soil. Workers in reflective vests and hard hats descend into a trench that smells like wet earth and metal. It's routine, until the bucket scrapes something that isn't supposed to be there. Stone, laid with purpose, brick in a pattern, a chamber that opens into darkness. In that moment, two worlds meet. The modern city wants speed. The past demands patience. Archaeologists arrive and do what they always do: slow everything down. They measure, they photograph, they sketch, they whisper to each other with the intensity of people who know they're standing at the edge of a rare conversation. Because the ground has been disturbed, the clock is suddenly running. Once exposed, ancient material can decay quickly. Water can seep in. Walls can collapse. Even well-meaning hands can destroy fragile clues. The first question is always practical. What is it? The second question is more unsettling. How old is it? Under some cities, the layers align with the story people already tell. Roman streets, beneath medieval walls, beneath modern asphalt. That's not shocking. It's expected. But occasionally, excavations reveal something that doesn't fit as neatly. A structure with construction methods that predate what should exist there. A burial practice that suggests a different cultural lineage. A sequence of layers that implies the city's origin is older than the legend printed on brochures. This is where official history feels less like a conspiracy and more like a habit. Cities prefer clean origin stories. A founder, a date, a myth with a clear moral. Real history is often less tidy. Settlements can shift location. Names can change. Cultures can merge. A founding can be more like a slow ignition than a single spark. So the expedition becomes a careful act of reconstruction. The team examines mortar, brick size, tool marks, soil composition. They look for coins or pottery shards, objects that can anchor a layer to a period. They perform dating where possible, knowing that every method has uncertainties and every result must be interpreted in context. And the tension rises when the evidence suggests continuity where there was supposed to be a gap. Perhaps a city believed to have begun in a certain era shows signs of organized building long before that. Perhaps a civilization thought to have arrived suddenly seems to have roots, slow-growing and local. Perhaps a supposed collapse looks less like an ending and more like a transformation. New materials, new rituals, but people still living, adapting, making do. The public often hears this as a battle. They were wrong. But the deeper story is more human. Most timelines are built from what survives, and what survives is shaped by chance. Fires erase libraries, floods bury neighborhoods, empires recycle stone. Poorer communities leave fewer durable monuments. Official narratives harden around the evidence we have, and they stay hardened until the ground offers more. In the tunnel's artificial light, the uncovered chamber feels like a pocket of preserved breath. Maybe it's a storeroom. Maybe it's a temple foundation. Maybe it's a simple wall that once kept livestock from wandering. The grandeur is not the point. The point is that it exists, silent proof that the city's story did not begin where people thought it began. For the archaeologists, the work ends not with fanfare, but with reports and debates and cautious phrasing. They do not claim the past has been rewritten. They claim it has been clarified. But for a listener, it can feel personal. If a city can forget its own beginnings, building right over them, then what does that say about memory in general? About families, communities, nations? About the way we choose a version of ourselves and then pave over the rest? Somewhere above, the city continues, buses, footsteps, rain in gutters, conversations in cafes. Beneath, the newly uncovered stones sit in cool air, holding their quiet contradiction. And the question lingers like dust in the tunnel light. How much of our certainty is simply what we haven't dug up yet? What if the map we trust is not wrong, just incomplete in the places we stopped looking? In school, continents are taught like settled facts. Edges outlined, mountains shaded, ocean floors left mostly blank, as if nothing of consequence happens there. We inherit a planet that feels fully known, at least in its broad shape. But the sea keeps a different kind of geography. Out on open water, where the horizon is a thin blade and the air smells of salt and diesel, a research ship becomes a moving laboratory. Cables spool, instruments drop overboard, screens flicker with the coded language of depth and density. The expedition isn't chasing a legend, it's tracing a boundary, one of the most fundamental boundaries in science, where one tectonic plate ends and another begins. Plate tectonics is one of the great triumphs of modern understanding. It explains why continents drift, why mountains rise, why earthquakes speak in sudden violence. It stitches together clues from magnetism, fossils, and seafloor, spreading into a coherent story. It's elegant. It's also built from data that is by necessity uneven. We know more about the surface of Mars than we do about large portions of our own ocean floor. So when an expedition charts a region and finds features that don't fit expectations, unexpected ridges, anomalous crust thickness, patterns of magnetic stripes that seem out of sequence, the response is not disbelief, it's attention. The mystery starts in the numbers. The sonar suggests a plateau where there shouldn't be one. Gravity readings hint at mass hidden beneath sediment. Rock samples suggest compositions that look more continental than oceanic, as if a piece of land were submerged and disguised. That is a dangerous thought, not because it's scandalous, but because it invites the mind towards stories too quickly. Sunken continent is a phrase that activates imagination. It's easy to leap to lost civilizations, drowned worlds, dramatic collapses. The ocean encourages myth. It has always been where people place what they cannot explain. But geology has its own lost worlds, and they're real in a quieter way. Continents do not behave like rigid plates of porcelain. They stretch, they thin, they tear. Pieces can subside under their own weight. Fragments can be stranded and buried, becoming microcontinents. Continental crust, marooned in ocean basins, neither fully land nor fully sea. The expedition's job is to test whether the anomaly is one of these fragments, and if so, what it implies about the history of the region. Teams drag dredges, retrieve rock, and read mineral compositions like fingerprints. Continental crust tends to be lighter, richer in certain minerals, older in its inherited structure. Oceanic crust is denser, more uniform, born from mid-ocean ridges in a different kind of fire. The difference matters because it tells a story of how Earth rearranged itself. When the evidence suggests continental-type rocks in the wrong place, the map begins to loosen. Not collapse, loosen. The accepted narrative of how a continent broke apart may need finer detail. A rift might have propagated differently. A plate boundary might have shifted. A fragment might have lingered above water longer than expected, then slowly drowned. This is how official history changes in science. not with a single dramatic contradiction, but with a boundary becoming more nuanced. The main structure holds, the details deepen, the planet's biography becomes more precise. Still, the emotional effect can be profound, because a submerged fragment of continent is a reminder. What we see above the waves is only part of the world. There are drowned landscapes out there, ancient river valleys cut when sea levels were lower, plains where animals once roamed, shelves where early humans may have walked along coastlines now far underwater. If a piece of continent can sink and hide in the deep, what else can sink with it? Not mythical empires necessarily. Sometimes the lost thing is simply context. The missing chapter of migration routes, the former shape of shorelines, the vanished places where people lit fires, told stories, and moved on. The expedition ends with updated charts, new models, and cautious headlines. A name may be proposed for the fragment, a tentative classification that will be argued in journals for years. But out on deck, watching the sun drop into the ocean like a coin into dark water, the feeling is older than science. It's the feeling that the world is larger than the version we keep in our heads. And it leaves us with a question as steady as the ship's slow wake. If the map can change beneath the waves, how many of our other known stories are simply drawn around the places we haven't measured yet? What if a cave could hold a climate memory so clear it makes our timelines feel too tidy? The entrance is rarely dramatic, just a slit in rock, a dark mouth in a hillside, sometimes half hidden by brush. But once you step inside, the air changes. It cools. It thickens. Sound softens. The world outside becomes distant, as if you've crossed a border into a slower country. Caves are not just empty spaces. They are machines of preservation. Over thousands of years, water drips through soil and stone, carrying tiny traces of the world above. Minerals, isotopes, bits of dust. Each drop lands, evaporates, leaves behind a microscopic layer. Layer after layer, a stalagmite grows like a slow candle of stone. And in that growth, the cave records time. Rainfall patterns, temperature shifts, vegetation changes. A climate diary written in calcite. The expedition in this chapter is a journey underground, not to find treasure, but to read these stone diaries with modern tools. Scientists haul equipment into darkness, drills, sampling tubes, portable lights. They move carefully because caves are fragile ecosystems and because the formations they study took longer to grow than any human institution has existed. The work begins with selection. Not every stalagmite tells a clean story. Some have interruptions, some have been broken and regrown. Some are contaminated by floods or human disturbance. Researchers look for formations that are undisturbed, layered like a well-bound book. They map the cave. They measure drip rates and humidity. They take samples with the delicacy of surgeons. Back in the lab, the stalagmite is sliced lengthwise. Under light, the layers appear, bands that may represent seasons or years, depending on growth rate. The team analyzes isotopes of oxygen and carbon, trace elements, and other chemical markers. They date the layers using methods that can anchor the timeline across tens of thousands of years. And then the surprise arrives, not as a single shocking result, but as a pattern. The cave record suggests periods of abrupt change, rapid drying, sudden shifts in monsoon intensity, swings that happen faster than the gentle curves we like to draw when telling the story of ancient climates. In some regions, the cave's layers align with known events, ice age pulses, shifts in ocean circulation. In others, the cave hints at local shocks that broader records smoothed over. This matters because human lives happen locally. A global average temperature can be stable, while a region dries enough to collapse agriculture. A small shift in a monsoon track can starve a river basin. A few decades of drought can push migrations, reshape borders, turn peaceful trade routes into contested ground. So the expedition's findings do something quietly revolutionary. They connect deep-time climate mechanics to the human scale. They suggest that certain historical transitions, settlements abandoned, new cultural patterns emerging, sudden population movements, may have been influenced by climate swings sharper than previously assumed, not in a deterministic way. Humans are not puppets, but in a contextual way. The stage changes the play. As always, the scientific response is careful. Caves are sensitive to local factors. A stalagmite records what drips into it from above, which depends on soil, vegetation, and geology. Researchers compare multiple caves across a region, looking for shared signals. They cross-check against lake sediments, ice cores, and tree rings where available. They publish not a grand overthrow, but a refined understanding. The climate system is capable of rapid reorganization, and caves can capture that tempo with unusual clarity. For an audience, the emotional effect is subtle but profound. We often imagine ancient people living in a world that changes slowly, while we live in a world that changes quickly. The cave record suggests a more complicated truth. Ancient people also lived through sudden shifts. Years when rain failed, decades when seasons felt wrong. Generations that watched familiar landscapes transform. Inside the cave, the stalagmites stand like silent witnesses. They have no opinion about empires or progress. They simply grew, one drop at a time, through eras of abundance and eras of stress. Their patience is almost unbearable. When the team exits into daylight, blinking against the sun, the ordinary world looks slightly different. The sky feels less guaranteed. The next rainfall feels less routine. Because in the cave's layers is a reminder that stability is not a permanent feature of Earth. It's a phase, and it leaves a question that follows you back to the surface. If stone can remember climate's sudden turns for tens of thousands of years, how well are we remembering the signals we're living through right now? What if the smallest fossils, too small to hold in your hand, could rearrange the story of when the oceans changed? In a quiet lab, under glass and light, the past can appear as dust. Marine sediments are not dramatic. They arrive on the seafloor slowly. A snowfall of dead plankton, silt from rivers, ash from distant eruptions. Over time, this accumulation becomes a layered archive. And inside those layers are microfossils, tiny shells and skeletons of organisms that lived in the water column and settled when they died. These microfossils are like clocks, not because they contain gears, but because species appear and disappear in patterns that can be dated and correlated across oceans. When a particular plankton species evolves, spreads, and then vanishes, it leaves a marker that scientists can trace through cores like a signature in time. The expedition begins offshore with drilling. A floating platform stabilizes against waves. A pipe descends thousands of meters through water, then into seabed. The drill bites into sediment that has not seen daylight in millions of years. Core after core rises, sealed, labeled, and carried into storage like a library's newest acquisitions. The team is not chasing romance. They're chasing a boundary in time. One of those transitions when Earth's systems shifted in ways that reshaped life. A change in ocean circulation. a cooling event, a period when oxygen levels dropped and then returned, the kind of event that, in textbooks, becomes a clean graph line. In the real world, it's a complicated story. Back in the lab, technicians slice the cores and sample the layers. Under microscopes, the microfossils come into view. Delicate spirals, tiny discs, intricate lattices. It's easy to forget you're looking at the remains of life. They resemble jewelry more than biology. Then comes the work of counting and sorting, species identification, relative abundance, chemical analysis. The team tracks how communities change over depth, which is also time. They look for the moment when one set of species yields to another. And then, in some cores, the sequence doesn't match the accepted timeline. A species appears too early. Another persists too late. A shift thought to be sudden looks gradual, or vice versa. The initial temptation is to assume error, mislabeling, contamination, reworking of sediments. Sometimes older fossils can be eroded and redeposited into younger layers, creating a false signal. Sometimes drilling disturbs the strata. Sometimes the interpretation is simply wrong. So the expedition turns into a process of elimination. They examine sediment structure for signs of disturbance. They compare the microfossil results with magnetic reversals recorded in the core. Earth's magnetic field flips at known times, and those flips can serve as independent anchors. They use isotope chemistry, like oxygen isotopes, to cross-check climate signals. They consult other cores from nearby regions. And gradually, a new interpretation begins to form. The ocean's change did not happen everywhere at once. It moved like a wave across basins, earlier in one region, delayed in another. The event in textbooks was not a single moment. It was a sequence of regional adjustments, stitched together into a global story after the fact. This is not a scandal. It is science doing what it's supposed to do, turning a simple narrative into a more accurate one. But it can feel like a small revolution because it touches something we rarely question: the assumption that Earth changes in synchronized beats. The microfossils suggest a different rhythm. They suggest that the ocean is not one uniform body, but a set of interconnected systems, each with its own inertia and thresholds. When circulation patterns shift, some regions respond immediately, others lag. Some become refugees, others become stress zones. For human history, this matters in a long-view way. Coastal climates, fisheries, storm patterns, these depend on ocean currents. If oceans can reorganize unevenly, then the environmental pressures shaping human societies could also have been uneven. A culture on one coast might face drought, while another thrives under stable rains, not because the whole world changed, but because the ocean's internal plumbing shifted. There is a humility in this kind of discovery. The smallest fossils on Earth reminding us that the biggest systems do not always move as one. The expedition ends with revised charts and new model simulations. The findings ripple into the wider scientific community, not as an attack on official history, but as a refinement of it. A reminder that our categories, epochs, events, transitions, are human conveniences laid over a world that does not always respect our boundaries. In the end, you're left with the image of a single microfossil, a shell smaller than a grain of sand, holding within it the timeline of an ocean shift. And the question it whispers is simple and unsettling. If something so tiny can change the way we date the sea's great turns, what other small witnesses have we ignored because we thought the story was already told? What if the desert, so often imagined as empty, was actually a vault, keeping evidence in plain sight until the wind decided to reveal it. From the air, the landscape looks like a parchment that's been erased and rewritten 1,000 times. Sand dunes ripple like waves frozen mid-motion. Dry basins spread out like pale scars. There are no trees to mark direction, no rivers to promise permanence. In a desert, the horizon teaches a person humility, and yet deserts remember. They remember because they are dry, because moisture, the great dissolver, doesn't arrive often enough to rot everything away, because a footprint can last longer here than it would in a forest, because stone tools can sit undisturbed for millennia, waiting for a boot to nudge them into view. The expedition begins with a survey, not a dramatic dig. Researchers drive slowly, scanning the ground. They follow satellite imagery and old aerial photographs. They look for subtle signs, a change in soil color, a faint line that might be an ancient shoreline, a scatter of rocks that doesn't match the surrounding geology. Then they find it, a field of objects that don't belong to nature's randomness. Stones chipped in patterns that show intention, points shaped for hunting, scrapers and blades, evidence of hands. And here is where the desert's gift becomes also its challenge. Tools can survive without the people who made them. A stone blade doesn't come with a date stamped on it. It doesn't announce which human lineage held it. It simply says, someone needed this, and they knew how to shape it. To turn a scatter of tools into a history, you need context. You need layers. You need to know whether the tools were left on the surface recently or exposed from deeper strata by erosion. You need to find associated materials that can be dated: charcoal from a fire, bones from prey, organic residue. The team works with careful skepticism. They map every find. They note elevation and proximity to what might once have been water. They search for the invisible, signs of ancient lakes, in places that now seem impossibly dry. Because deserts were not always deserts. In deep time, climates shift. Monsoons expand and retreat. Grasslands bloom and fade. What is sand today could have been a wetland once, supporting herds and drawing hunters. A green phase of a desert changes everything about where humans could have lived and how they could have moved. And then, in a small depression sheltered from wind, they find something better than a tool: an old shoreline layer, sediments that only settle in water. Within it, shells or plant remnants. Something that can be dated. The dates, when they come back, press against accepted assumptions. They suggest human presence in this region earlier than the neat story allows. Not impossibly early, not a rewriting of humanity's entire origin, but early enough to shift the map of migration. Early enough to imply that humans may have crossed landscapes and corridors at times we once thought were closed. This is the desert's quiet rebellion against simplification. It suggests that human movement was not a single wave, timed like a parade. It may have been pulses, explorations, retreats, returns, people following rain, following game, following the faint logic of survival across a world that kept changing its rules. The expedition team does not declare victory. They double-check the dating. They consider whether the sediments were reworked, older material moved into younger layers. They compare the tool styles to other regions. They look for genetic studies and other archaeological sites that might align with this earlier presence. But even the caution cannot erase the feeling. The desert has opened a door. The implications are both scientific and deeply human. If people were here earlier, they lived through climates that later hardened into aridity. They watched water vanish from basins that once held fish. They adapted, moved, or disappeared. Their traces remain not as grand monuments, but as practical objects, tools shaped to feed families, to endure, standing in the heat, with wind lifting fine sand against your legs. It's hard not to feel how thin the veil is between presence and disappearance. Entire lifetimes reduced to a few stones in the sun. And that leads to the chapter's lingering question. If the desert can preserve a hidden shoreline and the tools of those who stood beside it, how many other empty places on our maps are only empty because we arrived after the water was gone? And after the story had already blown half away? What if a single bone, misplaced by expectation, could force us to redraw the boundary between human and not yet? In a museum drawer, labels can feel like verdicts. A specimen gets a name, an age, a place in the family tree. It joins the quiet order of things. Visitors walk past glass and think, understood, completed, filed away. But fossils don't care about our filing systems. This expedition begins in a place most people never imagine as an adventure: a storage room. Metal cabinets, acid-free boxes, the smell of old paper and stone dust. A researcher opens a drawer, lifts a fragment, and notices something that doesn't quite match the label. At first, it's a small discomfort, a curve that seems wrong, a thickness where there should be delicacy, a joint surface that suggests a different kind of movement. The scientist turns the bone under light and feels that familiar tension, the one that lives between "I'm probably mistaken" and "this might matter." So the expedition moves from field to archive and then back again. To understand a bone, you need context. Where was it found? In what layer? With what other fossils? What was the sediment like? Was the site disturbed? Was it excavated carefully or hurriedly? Older digs can be messy. Notes can be incomplete. Provenance can be uncertain. Sometimes the history of the fossil is almost as important as the fossil itself. The team returns to the original site or to what remains of it. Maybe it's a cave, where layers can be jumbled by water or animals. Maybe it's an open-air deposit, where erosion can mix eras. Maybe it's a fissure fill, where bones from different times fall into the same crack, like loose pages into a gutter. They map the stratigraphy. They sample the sediments. They date what they can: volcanic ash layers, associated fauna, mineral deposits. They look for a reliable anchor, because without time, a fossil becomes a story without a calendar. Meanwhile, back in the lab, the bone is scanned and compared. Measurements are taken. Morphology is examined, the features that distinguish one species from another. The team compares it to known human ancestors and close relatives, looking for the subtle signatures that mark an evolutionary branch. Changes in pelvis shape, limb proportion, dental structure, cranial fragments, if any, are present. And the debate that follows is not theatrical. It's meticulous. It's often frustrating, because evolution is not a ladder. It is a braided river. Traits appear, overlap, and vanish. Two populations can share features without being the same species. A single fossil can represent variation, pathology, or a distinct lineage. The difference between new species and unusual individual can be agonizingly thin. Still, certain finds force the question. What if this bone has a combination of traits that doesn't fit the expected sequence? What if it suggests a hominin presence in a region earlier than believed? What if it hints at migration routes that were opened sooner, or at a diversity of human relatives living side by side longer than our clean charts imply? These possibilities don't require conspiracies to be challenging. They challenge us because they complicate identity. We like a simple story. There was us, and before us there were them, and then we replaced them. But the fossil record, again and again, hints at overlap. Multiple kinds of humans sharing landscapes, occasionally interbreeding, sometimes competing, sometimes simply coexisting. If the bones' age and anatomy hold up under scrutiny, the official story doesn't collapse. It becomes richer and less comforting. It becomes a story where humanity is not a single straight emergence, but a crowded dawn, full of cousins and near-cousins, experiments in survival, intelligence taking different shapes. The expedition culminates in papers, conferences, rebuttals. Some researchers argue for reclassification. Others argue the evidence is too thin. The debate may last years. That is not failure. That is how knowledge earns its steadiness. And for the listener, the emotional core lands in a different place. Not in who wins the argument, but in what the argument reveals about us. We are a species that wants clean origins. We want to know where we began, who our ancestors were, how the story leads inevitably to the present. But the bones suggest something humbler. We are the survivors of a tangled lineage. We are the inheritors of many near misses and side branches. Our official charts are not lies. They are snapshots, useful, provisional, waiting to be updated when a forgotten drawer opens or a field team finds one more fragment in the dust. If a single bone can disturb the story so deeply, what does that say about the story itself? Maybe the real question isn't whether history is wrong. Maybe it's whether we've been asking it to be simpler than it ever was. What if the sky itself, its dust, its ash, its subtle chemistry, could expose a missing chapter between then and now? Some expeditions begin with a destination. This one begins with a layer. In a cliff face or a road cut, you can sometimes see the earth like a sliced cake. Bands of sand, silt, clay, gravel, each laid down by different moods of water and wind. Most layers are mute in the way of ordinary time. Then, once in a while, there's a thin line that stands out, pale, powdery, almost delicate. Volcanic ash. Ash is a gift to science. It travels fast, settles widely, and becomes a timestamp. If you can match an ash layer to a known eruption, you can anchor the surrounding sediments with unusual confidence. And even when you can't match it, ash can be dated directly, turning uncertainty into something closer to a calendar. The expedition team arrives at a site where the story is supposed to be simple. The accepted sequence says, this climate phase happened, then that one. This species arrived, then another. This lake dried, then the desert took over. Neat lines, predictable steps. But the ash layer complicates the steps. They find it lodged between sediments that, according to prior models, shouldn't have that kind of time gap. Above and below, the deposits tell different environmental stories. One suggests wetter conditions, the other suggests aridity. The ash sits between them, like a bookmark in a book we thought we had already read. In the field, the team works like detectives. They sample the ash carefully, because contamination is easy. A bit of modern dust, a smear of older sediment, and the date becomes unreliable. They also sample the layers above and below, looking for pollen, microfossils, charcoal, anything that can triangulate climate and age. Back in the lab, the ash is analyzed grain by grain. Its chemical signature is compared to catalogs of eruptions. Each volcano has its own geochemical accent. The minerals within the ash, especially crystals like zircon, can be dated with techniques that turn radioactive decay into a clock. When the results arrive, the numbers do not neatly align with expectation. The ash layer indicates that the transition between the wet phase and the dry phase was not a slow fade over thousands of years, as the simplified narrative suggests. It was faster, or it happened earlier, or it happened in pulses, with a brief return of moisture before the final drying. The details depend on the site, but the theme is the same. The world changed in a way that doesn't fit our most comfortable pacing. The implications reach outward. If the transition was quicker, then ecosystems would have been stressed more suddenly. If it happened earlier, then human and animal migrations might need rethinking. If it pulsed, then there may have been windows of opportunity, brief periods when travel corridors opened, when lakes refilled, when vegetation returned long enough for life to regroup. This is not about overturning everything. It's about noticing the seams, so the expedition expands. The team searches for the same ash layer in other locations. If it appears across a region, it becomes a shared timestamp, a synchronized marker that can tie multiple sites into a single timeline. They collaborate with other labs to confirm the chemistry. They re-examine older excavations where the ash might have been overlooked or misidentified. And then comes the quiet revolution. A regional chronology begins to shift. Not drastically, but meaningfully. A story that once had one turning point now has several. A transition that was once a gentle slope now has steps. The past becomes less like a smooth road and more like uneven ground, periods of stability interrupted by sudden changes. For the public, it can feel unsettling. We want the world to change gradually because gradual change suggests control. But the ash layer is a reminder that Earth does not always offer gradual. Sometimes it offers thresholds, a system pushed until it snaps into a new configuration. Yet there is also comfort here, if you look closely. Because ash layers don't just mark catastrophe, they mark connection. The same eruption can dust distant lands, linking far-apart regions into a shared moment. The sky becomes a messenger, carrying time across valleys and seas. And so the chapter ends with a question that lingers like fine powder on a glove. If a thin line of ash can reshape our sense of when and how the world changed, what other thin lines, overlooked, dismissed, unmeasured, are still waiting in the Earth's layers to tell us the timing we got wrong? What if the story of the first Americans isn't a single doorway, but a hallway with many entrances, some of them now underwater? On the edge of the Pacific, dawn arrives softly. Fog hangs low over the water, and the coastline feels like a boundary between worlds, the solid certainty of land and the moving, reflective uncertainty of sea. It's easy to forget that this boundary has wandered over time. During the last ice age, sea levels were lower. The shoreline sat miles farther out. The ocean we see today is covering what used to be a wide coastal plain. If early people traveled along that ancient edge, many of their camps would now lie drowned. Fires extinguished by rising water, tools buried under sediment, stories sealed away in salt. The expedition begins with that awareness. To find the earliest coastal traces, you may have to search where no one can walk. A research vessel moves along the continental shelf, towing instruments that read the seafloor like fingers reading Braille. Sonar paints contours. Sub-bottom profilers peer into sediment layers. The team is looking for ancient river channels, terraces, and sheltered coves, places where people would have found fresh water, predictable food, and protection from storms. Places where a small group could have paused, cooked, repaired tools, and watched the sea. The map that emerges is not just geography. It's a hypothesis about human behavior. It's a guess at where an ancient person might have chosen to stop. Then come the samples. Cores are taken from promising spots. In each core, the researchers search for subtle signs of human presence. Charcoal from ancient fires, concentrations of certain minerals, anomalous layers that suggest disturbance. Sometimes they look for microscopic remains, tiny fragments of burned plant matter, residues, changes in pollen that might reflect human activity. They also search coastal caves and uplifted terraces on land where rising or shifting geology may have preserved ancient levels above today's reach. The tension here is not only scientific, it's cultural. The peopling of the Americas has been told, for a long time, as a clean narrative, a land bridge, a corridor, a wave of migration, a famous tool culture marking the first. That story became a comfortable anchor. It offered a clear beginning. But the evidence gathered over recent decades has asked for a more complicated beginning. Earlier dates at inland sites, different tool traditions, hints of multiple movements, and the growing suspicion that coastal travel could have been a major route long before the interior ice-free corridor was open. This expedition adds to that pressure not with a single smoking gun, but with a mosaic of plausibility. Ancient landscapes mapped beneath the waves. Dates that suggest habitable coastal refuges existed when the interior was still inhospitable. Sediment sequences that show stability in certain bays. Cores that hint at charcoal in layers old enough to matter. None of it is easy evidence. Underwater archaeology is expensive, slow, and constrained by visibility and preservation. A fire pit underwater is not a fire pit on land. It is scattered carbon, mixed by currents, blurred by time. The team must work with probabilities and converging lines of data, not the clean certainty of a stone wall. So the expedition's claims are cautious. They don't declare, "We found the first campsite." They say something more restrained and more meaningful. The coastal route was likely viable earlier than some models assumed, and the submerged shelf may hold key evidence still undiscovered. This reshapes official history in the way a shoreline reshapes under tide. The old story isn't necessarily false, it's narrower than reality. A single doorway becomes a hallway, and in that widening, a new kind of respect enters the narrative. Early people were not waiting at a gate for an ice corridor to open. They were living, adapting, exploring, making decisions in real time. They followed kelp forests, rich with fish and shellfish. They traveled by boat or along beaches. They learned the moods of coastal weather. They found ways to survive in places that modern people with modern equipment still find challenging. As the ship returns to port, the ocean looks unchanged, endless, calm, indifferent. But for the team, it now feels like an archive with locked rooms. The chapter leaves us with a quiet question, as steady as waves against the hull. If the sea has swallowed some of the earliest chapters of human arrival, how many of our origin stories are shaped not by what happened, but by what the rising water chose to hide? What if the oldest writing wasn't on paper or clay, but etched into the very idea of what we think is possible? There are discoveries that change a date on a timeline. And then there are discoveries that change the shape of the timeline itself, forcing us to rethink what a human mind or a human culture could do at a certain moment. This chapter begins in a place that feels like a threshold. Stone rising from earth, massive and silent, aligned with sky. Not a palace, not a fortress, not a city, something older and stranger. A sight that doesn't fit the old expectation that complex building requires farming, and farming requires settled life, and settled life requires time. For decades, a simple sequence dominated popular imagination. Humans hunted, then farmed, then built monuments. Progress as a staircase. It felt logical. And then fieldwork revealed a different order, monumental structures that appear to predate agriculture, or at least predate the fully settled farming lifestyle we assumed must come first. Pillars carved with animals, arrangements too deliberate to be accidental, evidence of gathering and organizing labor at a scale that suggests more than small, isolated bands. The expedition is as much about patience as it is about awe. Researchers excavate slowly because early layers are fragile. They analyze soil and micro-remains to understand what people were eating and how they were living. They study tool marks to infer the technology available. They date organic material found in association, charcoal from fires, fragments of bone, plant remains. Every sample is a thread in a bigger fabric. The surprise is not that ancient people were capable. They always were. The surprise is how early that capability expresses itself in stone. To build something monumental requires coordination. It requires shared purpose. It requires a story large enough to gather people. Whether that story is spiritual, social, seasonal, or practical, it creates a new picture of early humanity, not just surviving, but organizing meaning. This doesn't mean agriculture didn't matter. It mattered enormously. But the expedition's findings suggest the relationship may not be a one-way ladder. Perhaps large gathering sites helped create the social networks that made farming worthwhile. Perhaps ritual and community came first, and agriculture followed as a support system. Perhaps the drive to build and gather was not an endpoint of civilization, but one of its engines. Here, official history shifts in a way that is surprisingly intimate. We often underestimate our ancestors by projecting our own modern assumptions backward. We imagine them as less complex because we associate complexity with cities, with writing, with metal. But complexity can exist without those things. It can exist in shared belief, in seasonal gatherings, in coordinated effort. It can exist in the decision to carve an animal into stone, not because it helps you hunt, but because it helps you understand your place in the world. The expedition's work becomes a conversation with humility. The team must resist the temptation to romanticize. Ancient monumentality does not automatically mean utopia or enlightenment. It could also mean hierarchy, coercion, conflict. But it does mean intention. It means imagination, capable of reaching beyond immediate survival. As excavation continues, the site reveals layers of building and burial, of reuse and redesign. It is not one event frozen in time. It is a long relationship between people and place. And that relationship suggests continuity, communities returning, maintaining traditions, adapting them. For the listener, the emotional revelation is subtle. The past is not a primitive preface to the real story. It is the story. The human mind has been making meaning for a very long time. Standing among carved stone, you can feel the difference between knowledge and wisdom. Knowledge gives you dates. Wisdom gives you perspective. The chapter ends with an open question that feels less like a puzzle and more like an invitation. If ancient people could gather, imagine, and build at this scale before the world we call civilization officially began, what other capacities, art, memory, empathy, belief, have we been placing too late on the timeline simply because we assumed they had to arrive after everything else. What if the point of these expeditions isn't that history was wrong, but that certainty was always a temporary shelter? If you lay the chapters side by side, a pattern emerges, not of scandal, but of revision, a limestone riverbed that raises uncomfortable questions about tracks and time, a seafloor geometry that forces us to ask how we recognize intention. Ice cores that show climate can change with a speed that feels almost personal. Caves that store rainfall and drought like a stone heartbeat. Microfossils that rearrange the timing of ocean shifts. Desert tools that appear where emptiness was assumed. A mislabeled bone that reminds us how crowded our ancestry was. A thin ash layer that becomes a timestamp in a story we thought was smooth. A drowned coastline that hints our earliest footsteps may be underwater. A monumental site that suggests meaning and organization may have arrived earlier than our tidy progress charts allow. None of these discoveries demand a melodrama. They do not require a villain. They don't even require a hero in the traditional sense. They require something rarer, the willingness to be corrected. That's an uncomfortable virtue. It's much easier to cling to the version of the past that feels stable. It's comforting to believe that the world is fully mapped, that the timeline is settled, that the big questions have been answered and the remaining ones are details. But the Earth keeps offering details that behave like big questions. The past keeps showing up where it shouldn't. And maybe that's the wrong way to phrase it. Maybe the problem isn't that the past is misbehaving. Maybe the problem is that we expect it to behave at all. We ask history to be a courtroom, where evidence delivers final verdicts. But history is more like weather. It moves through us, shapes us, leaves traces we can read only imperfectly. The archives are incomplete by nature. The ocean swallows coastlines, rivers rearrange their beds, fires erase records, cities build over themselves. Even memory, our most intimate archive, edits without permission. So when we say official history, what we often mean is the best story built from the best evidence available at the time. That story is not a lie, it's a draft. Science, at its healthiest, is the art of living with drafts. It is an agreement to keep asking, even when the answer is inconvenient. It is a discipline of doubt, not cynicism, but careful uncertainty paired with method. Measure again. Test another core. Date the layer twice. Compare the cave record to the ice record. Admit when the model doesn't fit, and then build a better model. That process can look slow from the outside. It can look like stubbornness. Sometimes it is. Humans are humans, even in lab coats. We have biases, loyalties, pride, but the deeper current is self-correction. Over time, evidence accumulates like sediment. The shape of the story shifts. And that is the humanistic insight at the center of this series. Knowledge is not a trophy. It's a relationship with the world, with the past, and with one another. It asks for patience. It asks for humility. It asks us to hold two truths at once, that we must be skeptical of easy claims and that we must remain open to surprise. Because surprise is not a failure of history. It is history doing what it has always done, revealing itself unevenly. If there is a single image to carry forward, it might be this: a researcher in a wind-blown place, holding something small, a shard, a core sample, a thin ash line in their palm. Around them, the world looks ordinary, but in that small object is a crack in certainty, a new angle of light. Not enough to rebuild the whole story alone, but enough to change how the story is read. In the end, we don't inherit the past as a finished book. We inherit it as a scattered library. Some shelves burned, some volumes submerged, some pages still buried. And the final question isn't whether history can be proven wrong. The question is gentler and harder. When the next expedition returns with evidence that doesn't fit our current draft, will we have the courage to rewrite the story without losing our care, our rigor, or our compassion for the people who lived it? Because the past is not just what happened. It's what we're still learning to understand.